It'll be, well, here we are, the historical missed meeting without Luke. I think this is the first one. Thus, why it's historical. Uh, I'm drinking some Coke here. How you guys are doing? Go ahead, say something. Good.
Very good. For the record,
Yeah.
I am good.
Okay, for the record. Great. So we're gonna review a code today. I don't understand why this. Yeah, whatever. It's crazy. Okay, now I can see why. One of the things that Luke was complaining before, it has this red bar on top of the screen that doesn't allow me to actually see the top of my screen. But I fix it. Well, I will eventually.
You don't have to share a single window. You can
Oh,
share the
it's
whole
much
screen.
better. It's much better because I can actually make it bigger or smaller here.
Okay.
You see? So you can actually see more or less parts of the code. So I can actually make it bigger for you. Anyways, I don't remember how to do this. Anyways, so Luke asked me to write a code about how to make gene groups, basically. So I read a paper a paper last year compared, where is this paper? It was somewhere in here. Anyways, I won't find it, but like I'll send it out. It will be on the documentation. Um, Actually, I wrote the documentation for this thing here, so we probably should see this one first. Okay. Um, so as you can see, this is a gene group finder. The idea is to actually go through the genome and look, basically group things that are close together. Like, imagine that in the ideal case, this would be an operon, okay? So last year, somebody wrote a software called, I don't remember the name, but they basically did a meta predictor, which is this idea of using several different tools and combining them with a support vector machine and to weight these contributions and actually make a better prediction overall. Okay. Hold on a second. I need to mute my phone here. I'm going to keep beeping. Okay. So what they found is actually finding genes that are close together are very easy. Is very, very easy. And then the ones that are orphans is not that easy. Well, Luke wants us to find the ones that are close together. So the only thing you need to know is if they are actually, in fact, close enough together. I don't exactly understood why Luke wants to do this, but like I guess this is the idea. If two genes are in the same operon and then a response regulator and a histidine kinase, they are part of the same two components. The majority of the work that has been done in the past 5 years is to try to find out genes that are apart from each other that are still coupled. And to do that, people use different methodologies like phylogenetic profiling and phylogenetic mirrors and things like this. So a coevolution. And this is not, by far, this is not what we want. So it's very simple problem at the end of the day. you actually, here's the input, right? So
right. So they're all different methods that needs to be done by experts carefully, manually. It's not something that you can easily do automatically, like phylogenetic profiling, revealing the homolog first, and do profiling and that kind of stuff. So they cannot be easily done. So
no.
this is the best way we can do, right?
Well, this software, for example, they have like a very, because histidine kinase and responsive regulators are so prominent in prokaryotes, they have a very nice, and a lot of research has been done on it. So they have a very good benchmark data set. So they can train a very good machine learning algorithm to go through the genomes and actually make very good predictions automatically. That's what this meta predictor does. It involves 6 different types of predictions, and then actually when you put them together, they work better than anybody else. Great. They have like a 96%, not 96%, 96 what they call area under the rock curve. I wasn't very familiar with that measure, but you guys probably are.
Out of 100?
I think so. That's what it looks like. So it seems to be really decent. The rates of like false negatives are pretty.
What are their test sets?
Well, I'll send you the paper. Those are details. And
it's 2002. There wouldn't have been a lot of genomes then, right?
Well, this is 2015.
Oh, okay.
Yeah. So this paper that I mentioned here, this is the one that actually we're gonna give us the cutoff. Because this is the one that actually doesn't do any of these fancy shenanigans. They just actually look for things that are close. But basically, it's a very cool paper. You guys should look at. They basically go through all the genomes that they had and find out what is the main distance between 2 genes. And then they find this peak at a certain number, and then the guys that proposed having the cutoff genes between two genes in the same operon or gene cluster should be around 200 base pairs.
So if you do 200 base pairs, how many of the what will be your coverage?
No, yeah. The point is, I don't know.
Okay.
And I think nobody knows because nobody's very good at predicting operons.
Okay.
So to predict operons is a completely different ballgame. There are databases for operons for a single organism because that's the best they can do. Right? To my knowledge, there's nothing that actually is high throughput. You just dump your genome in something and then you just pick the operons for you.
Let me ask you a question. How hard it is to implement the methods in the 2015 paper? Is it very hard?
They're not a single genome dependent. So we're going to have to actually do through groups of genomes. You see what I'm saying? And plus, they're not going to only collect like pairs of histidine kinase response regulators. They're going to find out orphans as well. They're going to make predictions about orphan pairs. So it will be better, but this is a way beyond the scope of MIST automatic dumping of. So
do you think it will be better though?
What?
So you think that it will be better to have such a thing?
It's not the scope that we want, right? Like, I mean, it is an ongoing research field.
Right.
Well, we know that actually finding the pairs that are together, those are easy.
Right.
So what the previous MIST we used to do is like you find the pair by being close together and guarantee that these guys work. And then you actually find the orphans and list them. Here are the orphans. So you can actually do your homework and find out how this actually do. Like that's what MIST tells the user basically, right? It's like here are all the orphans. Now you actually go there and solve the puzzle. But the idea is basically using you guys know about this, right? Like if these things co-evolve, they might interact. Actually, they look at the not phylogenetic profile. They look at multiple sequence alignments, and the paper says like this is very this relies a lot on this quality of the sequence alignments and they perform like pairwise thing. It's a mess. But anyways, it's an entire new field. Like there are people with entire careers just to do this. So we should step out, as I think Luke intended anyways. The idea is just let's show the pairs and keep doing what Missy used to do. So it's like let's do the same or a little better in prediction from this. So this is the problem. The problem is like involves more than one genome to find out the pairs of orphans histidine kinase responsive regulators, because you need to compare with the other things. All right?
Okay.
Okay, so the purpose here is very, very simple. So this is the expected input. So it's just a list of positions of genes, where it starts, where it stops, and they strand.
Is it full genome?
No, it can be anything. It can be like 3 of those.
Okay.
Right? Like it's just you just dump. It can be the full genome. It can be the entire database for what I care.
Okay.
And then the output is basically making groups. You see, each one of these lines are groups of these genes, and each one of these groups are basically they obey 2 things, 2 rules. The rules are actually I should put the rules here while we're talking because it's easier. Oh yeah, I have to click not on the screen share, but on the Hangout. Okay. There's basically rules. There's 2 rules. So rule number 1: genes are grouped together if they are less than 200 base pairs apart from each other.
Are you considering
sequence
opposite strands as well here?
That's the rule number 2. They all need to be the same strand. That's it, right? So.
Okay. It's the single rule, I believe.
Well, you will see that there's 2 ifs there. Okay, so this is basically what it is. And then the way to use is you require the class. Luke's going to make this become a function later, but for right now it's a class. Just create a new class, and then you basically parse your yeah, this is a different name here, right? Like it's the file, basically, with your JSON formatted. What?
So why in your expected output, why do you have like 2 different lines like this? The first something and this is the second.
The first is one of the groups. The second is another group. The third would be another group, and then those are groups of the genes that you send out.
Array of groups, yeah. I mean.
It's an array of groups, yes.
Oh, okay.
Okay.
So input is going to be multiple gene positions.
A what? Say again?
So yes, like your input is going to be like multiple gene positions, right?
Yeah, that's 3000%
continuation,
I believe, order.
That's what it is. You basically like stream. You don't stream yet, but I think the idea is like eventually you stream your genome through it, and then it's gonna basically classify like this. It's not built to stream, and then you know why. You will know why in a second. I need to fix this too. So this is not gene position string. This is gene position input, which is basically I don't even know how to write this. It's basically a JSON file.
You already did that at the line 40, I believe.
That's right. That's what it is. I didn't do the require in the right place.
The same name. But
that's right. No. It's exactly how it is. I did right. I'm an idiot. Okay. Let's save this. Okay, the idea here is the following. So this will load Oh, this is what is missing that is threw me out. Node.js.
Right.
Yeah.
Maybe not.
No, maybe not. Let's just check this so we have this done.
Probably not. Require doesn't need to have that JS
Yes.
version.
Oh, hold on. Yeah, JS. Great. Well, we can check the test here because it works. Yeah, you see, there's a JS. No, there's no JS. That's great. Okay, cool. You're right. Also, at the end, I was right all. Okay, good. I should stop down myself here. Okay, I was a better David that day. So basically, this requires something that Luke taught me last week. I don't know if you guys knew. You can basically like require like this without the .js, and then even if your file looks like this, will become a JSON object instead of a gene position string is going to become just a JSON object. If you didn't know that, that's a great thing to do. Now I do. So then you start your class, and then like you do your parsing, and then you have your results are stored in the methods, in the property groups of the gene group finder. It's pretty dumb, but that's how I did. So let's look at the code now. It's fairly easy. So you actually define the constants, the distance cutoff, and take a look at documentation for it. And then, of course, you need to have a minimum group size. So I put 2.
What does it mean?
Well, you need to have at least 2 in the group.
Okay.
To make a group, right?
Well, it's always 2. It's not.
You can have 1.
Changeable. No, you cannot. If you have 1, you would have group number equals to the gene number, right?
No, you can actually. This is a minimum group. So, for example, you can have orphan genes, right?
I see.
Genes that are separate from everybody, and then they will be part of the group. And actually, every time things actually switch, strains will be part of a single group and so on. So,
Okay.
You're limited to actually just spill things that are more than 2 together. More than 1, actually. So
Yeah.
this is the minimum group size. Okay. So when you start, you basically started these groups with a. It doesn't need this constructor. You will see why. Anyways, this is the part that I cannot make work. Is the throw error? But like I think we probably Ogun might actually be able to help me with this. But like ideally. Yeah, we may go through this right now. But
Did you write that is valid object?
No. But anyways, it's not just that. Like nothing really works with throw, even the simplest way of doing it. So this is basically me trying to do a bunch of other things. Oh yeah, I did it right. Yes, it's here. Okay. Okay, so the idea is we start groups with a 0. It's just a list. And this is why it cannot be streamed right now, because if you made a mess with your genes, I sort them for you.
David, before you move further, may I tell you my thoughts about that try and catch?
Yeah.
So I think you shouldn't do that right away over there, because every time, so we will be using it in our algorithm, and it is an unnecessary check because we will be knowing what to send. So what we can do is we can do promises. We always use promises, and it can always return an error if something is not right. So I would avoid that try and catch for now.
I agree with you. I just don't know how to use promises yet.
Okay.
Okay, I agree with you completely. So the idea is if somebody actually throws something that is not the object that I'm expecting, I just work on it.
I see.
That's the idea. Okay, so keep going. So if you actually messed up your sequence that you're sending to me, I organize them for you. You understand this part, right?
Wow. No, I didn't. I missed it.
So when you actually give your input and your input is not in sequence, you just give me like a bunch of genes for some reason. Okay. I sort them out for you, so I put them in order.
Okay.
Actually understanding how sort works and how you can actually make any function here to sort things, it really was a very illuminating day for me when I actually spent like 15 minutes to learn how this thing works. It's really cool. So I suggest you guys look in the
It's a
documentation.
very simple command.
But you can make a very complicated function in here, and this will actually work out. So it's great. You can have multiple indices. Like it's just beautiful. I love it. Okay.
Another question. So it will, if things are ordered, it will still spend some time here in the algorithm, right?
Right.
So maybe if we know what we are sending, if we know that we are sending the genes in order, maybe we don't need that.
Right, but I don't know.
Okay. I'm just thinking about it.
Yeah.
Go ahead.
For example, you can actually put like another thing here, order, right? On the input. And then if the guy tells me that it's ordered.
Actually, you don't really need to have the genes in order, right? You just look at their start and end points, and you just assign groups. So it doesn't matter if they come in order.
Well, if you want to compare to each one of the groups, every single one that comes in, yes. But you will see that my algorithm needs them in order.
I see. Okay.
Because I compare just to the next one.
I see. Okay.
Yeah, you can definitely do that, but I will require me another 4 here that go to each one of the groups and find if there's anybody with like a starting or stopping point that actually matches my starting or stopping point. Right?
Mm-hmm. So
that will be the generalization of it.
So you will not be assigning any arbitrary group number to groups?
No, I just make them as they come.
Do you think we might need it? Because, for example, if we want protein A, if you want to see other members of the groups that protein A belongs to,
they'll be in order already.
Huh?
They'll be in order?
Yeah, I see, but where are you going to store this data?
So the output is like this.
Yeah, I know.
That's how it is.
But how do you envision it to be in the database? That's my question.
This.
Mm-hmm.
So
really?
Yeah. Well, this is what the requirements that actually Luke gave me on the task in Pivotal.
Okay. So it's beyond your task.
Yeah, it's beyond my task exactly right now. Okay. So I don't know what he's gonna do with this, but this is what he wanted. Yeah, I tried to get more details from Luke, but like he wisely didn't give me much more than what I needed.
Because I think that for querying purposes, it will be easier to give each group a number.
Absolutely. Actually, it would be easier to give exactly. It would be easier to actually have a dictionary, basically, right? Of like the gene and then the order that they come in, for example, and like if they're from which group they belong, right? This is easier. But I think that's the task that he proposed, and I'm sure he has an idea there.
Okay.
Okay, so the idea goes like this. So for each element of the object, you have the element, and do I use I? I probably did in the beginning, but I don't. I don't anymore. Okay, then I will erase it. So I here would be the index. You guys know this, right? Mm-hmm. So as you go through the elements are the objects, and then I is the index of the element inside the objects in general. Okay, so the first task is look at, so I started with the group, and the group has items, the temporary group has items and strained. Okay? So you look at the length of items, and if it's 0, you push the first one as the temporary group. Okay?
Mm-hmm.
And then you put like the first element has the items, the element is the first one in the group, and then the element strained is the strain of the temporary group now. Okay, now pick the second one. The length is not 0, so this is the test. So the test is made of 2 things. Is it the same strained? And the second test is the new element starting position minus the last element in the group of the temporary group items. This is what it is, right? Like temporary items length minus 1, which is basically the last element of temporary group items, the stop direction is smaller than the distance cutoff. Okay? Basically, is the starting of the new element the same as the end of the last element that was pushed to the group? If it is, smaller than 200, all right? Like the distance between them. So if it is, you push the element to the group. Now you have 2 elements, and then you keep doing this until, if you don't satisfy this condition, now you do this. So if the group is bigger, if the size of the group, the number of items in the item of the temporary group is bigger than the minimum group size, and groups, you push to groups, which is defined up here, the temporary group items. So all the elements inside items goes inside, becomes a new group in the groups. Then the next line is like you restart hold on. Yes. So you restart the temporary group with the element that is currently in, you're checking because you already failed, so it doesn't belong to the current temporary group. So now you restart the next group with the element that just came in. And then you have the new strand, depends on the new element strand. And then you keep doing this over and over.
Got you.
Until you get like this, and then you push these groups to groups, and that's it.
After the loop, right?
After the loop, yes.
Okay. So it's very simple, straightforward. So my question is, I don't know. That's why I'm asking. So if 2 genes are on opposite strands, how would their start numbers be?
The same. I checked. I thought they would have like different starting and ending numbers, but like they're all the same. It's in sequence. They just switch the strand.
Okay, got it. So it means that if a gene B is on strand minus, its start point is actually its last nucleotide.
Yes. Yes.
Okay. Nice.
So this, I had to check that too. I didn't know.
Okay.
Yeah, at least in the genomes that I checked, it was like this. I didn't find it like a rule or anything. Okay, so and then the test that I make, like, is it a valid test? Basically, I just wanted to throw an error if the object doesn't have these properties in each one of them. So I test each one of the objects you sent to me in each one of the items inside the objects container, and then like to figure out if they have all the properties. If they don't, UBOR can say that they don't have the strand, or they don't have one of the things that are required. So I'm not gonna do anything with their stuff. Okay.
Yes, but thinking about tens of thousands genes and check it for each genome.
No, I think it's gonna be easy. I would like to actually go for production on this, just to see how this algorithm will do. Okay. This is quicker than anything else that I could think of, because just go once, and sorting first and then going through, it's, in my opinion, is faster than actually picking each one of the groups and actually searching everybody for every item that comes in.
No, I don't think so. If you index it, if you occupy the memory for that, it will be.
So you want to index
this one? I mean, what I mean is, if you just create a dictionary, it wouldn't be that hard. It will be actually faster. I'm sure about it, because you're already running the loop. To gain from time, you just occupy some memory by just having a dictionary stored in the memory, and that's it. Instead of sorting, you wouldn't sort it. Anyways.
I'm thinking about, so you only keep...
So sorting spends time, but with dictionary, with the cost of occupying some memory, it will be faster.
Oh, I see what you mean, I think. So basically what would you do is like making an object that would have as the key the starting and stop of the last the starting and the end of the group,
Exactly.
and then you keep actually storing things.
Exactly. Minimum and maximum.
Right. Right. Yeah.
Yeah.
That sounds cool. Yeah. I don't know if it'll be faster than this.
It should
Because
be.
you still actually required to search through the entire dictionary to find the right thing in there. But I don't know.
No, it's index. It's instant. No, it's not. I see your point.
Yeah.
I see your point.
You have to go through it, right? You have to actually, basically, when you ask, like, is this in there, you basically have to loop through it.
Right. You're right.
Even though you're not doing it, somebody's doing it.
Yep. I got it. Correct.
That will be very interesting. I'm very interested in these things because my next application is gonna rely a lot on instant calculations, and then I'm very interested in timing because it's gonna be all done in the client side. So yeah, I'm very interested on the speed of these things. We should discuss this later.
Yeah.
Anyways, so this is my test. Basically, this is my testing. My test input. It's something like this. I basically went through one of the genomes and I made it by hand.
How many genes are there?
It's like not even 10.
Okay.
It's basically like testing each one of the ideas, right? Like, so these three guys are one group. This is too far from this, should be by itself. Then there's another guy that should be in the second group. This is like should be in the same group because they're close enough, but they're not because different strain. This guy should be added to that because they're the same strain and close enough. This is different strain again, but is alone, so then shouldn't go anywhere, and this guy should actually recover, and so on. So
200 bases are good enough to be in the same group?
That's what I read.
Okay.
That's based on that publication. Yeah.
For the negative strand, hold on, are you looking at stops or are you looking at start?
So this is what I'm going to ask. So it's the same. As the gene comes, the starting and the stop is always from left to right. Doesn't matter this time. Yeah.
I would try. I'm sure it will work because you already checked the strand. Yeah. So, but what I would do is the one that is the first minus strand. I would make it very close to the the fifth gene within the 200 bases range, so that to see if they are clustered together or not.
Oh yeah. Isn't it? I think they are.
No, it's 1,000, but it's more than 1,000.
I made a mistake here on the stop. You see?
Yeah.
There's because I made by hand, so I will fix this later. But it's supposed to be close enough, and they will switch because they switch later.
Yeah.
So yeah, because for example, you have to start a group with a single gene here.
You already have to
switch.
Have the similar thing at the 7th. Yes.
It's in there. It's in there somewhere.
Yep.
I just need to actually go back and fix this. Put a random number because these are not the real genes. Just a number that makes sense.
Actually, one of the genes starts before the other one ends at the opposite strand. Okay. Yeah.
So actually, there will be there are genomes with this, right? Like they're badly annotated, and then the genes have like different starting points. When you go through MIS, you'll see plenty of this case. By the way, if Igor is listening, his azospirillin genome is very, very shitty. so
you mentioned that a couple of times already.
I do that every time I can because it's awful. So it's so bad that it has multiple starting points for the same gene. So MIS get very confused about them. Anyways, yeah, you have like genes that actually are longer than the genes inside the operon. So badly annotated that is. I'm probably going to send an email to Kirill ranting about this, just to remind him how shitty this is. Anyways. Okay. Sorry, Luke, for the jargon here, but it is really bad. Anyways. Okay, so then the test is very easy, so you should actually just parse the input right away. It does what it needs to do. There's expected results, so make 3 groups, and it does. It's a gorgeous thing. Now, it should throw errors through this, and it does. Well, I'm not sure. So this is the part that I stopped that I need to actually look help. Looks help is basically I test with several fixtures here that it should not go, it should be a fail to this one, but it shouldn't fail on this one. And I was just want to actually the npm test bork on me, but it doesn't. It actually just goes through even though I passed something that should be a throwing error. So I don't know how to do this. That's why I haven't actually finished. But I'm not, when Luke comes back from his stuff, we can actually go through and actually make this test better.
So, Davi, another question.
Mm-hmm.
So, when you're saying input and output,
yeah,
right? So those arrays should map exactly, right? So the first element should correspond to the first result that you get in your output.
More or less. Let's just unless if they're not part of any group, so then they won't.
Yeah. So for singletons, how do you?
Singletons, good way.
Like,
good.
Sorry, whatever.
That's that's great. I mean, thanks for.
So if you have an orphan gene, like
no singletons, I like it.
Okay, fine. A singleton, then in your output, how do you know that? Like
I just don't. It will never be there because of right here. So I tested before.
But what's the problem if you include that?
Oh, it's just too big, and it's not grouping. Like this is the idea to actually find groups of genes, unless if you want a group of one. But there's no problem. I theoretically can just dump this, and then just.
I'm just thinking. So you get your output, but then how do you? And it won't correspond, right? If there are some genes that are singletons, how do you know like which is your result, the corresponding result in your output?
You have the starting and stopping genes for your input, so you know which ones they are, right?
Oh, okay.
So you can compare back
to everything, right?
Oh yeah. I mean, the problem is, but I agree with Ogun's idea is nice. I like this idea of actually building a dictionary, but I think Luke has a pipeline in his head for the downstream of this. And that's why he asked what he asked.
I think you can still go ahead and do that. Like for example, your first gene in your input is like the singleton, and the second has a group of 4 genes. So when you're generating the output, like if you still continue with that, so in the first gene should be like only one element group, whatever.
You can just if you just make group size here 1.
Yeah,
golden.
So I'm saying that way you have like a continuous mapping, right? So with the index, you know exactly, and further downstream you can store it the way you want.
Right. That's fine. You just need to alter this.
Yeah.
And then put it equals.
I'm just wondering, like,
or getting rid of this if.
Yeah, I mean, I don't think it's going to be like a major memory issue, like ignoring the single genes as such. Like it.
I agree with you. But this is like, because this is actually a tool, and then it will be part of our toolbox, some people might actually want to use this a specific function to do something else. So they will alter the minimum group size to something else. And then, well,
but that can be easily done, right? You can just loop over everything and look at the sizes.
Right.
I mean, the only thing I'm saying is rather than, so the way it is set up now, you have to look at every element to find out, rather than just looking at the index.
Well, in fact, you have to go through the objects itself.
Yeah, that's what. So instead of that, if you just get rid of the minimum group size and just map everything, then you just need to go through like the index and you know exactly what your result is.
Right. I agree with you. But there are probably other ways of doing this as well, but like this is my requirement from Luke's task.
Okay. So Luke mentioned the group size.
Yeah, he defined to actually he wanted the output like this way.
Okay.
So yeah, but I like your guys' idea. I think actually Luke should take in consideration. I actually don't know what he's gonna use this for exactly, but they're definitely probably. It depends, right? Like you can do this I don't know. Yeah, I definitely thought about like other ways to do this. The reason why this is a constant here is because I thought about that. I mean,
Okay.
what I didn't think about was the dictionary idea that Ogun made, like just growing these groups dynamically. But that will require a for loop for searching them. Maybe not. Anyways.
Okay.
So this is what I got. Okay. Oh, I forgot to mention one thing. I have another meeting in 15 minutes.
That's okay.
That's fine.
Okay, cool. It's kind of nice. My boss is actually in vacation, so I'm going to the office only when I have meetings. I mainly work from here. And I go in flip-flops and shorts. It's great. California, baby. California. I actually go in flip-flops and shorts when he's here too. It's just the fact that I don't go as much. The problem is some people complain because I'm in the wet lab part of the lab, not with the other computational dorks. So
Okay.
yeah, it's a little frowned upon. Who cares? Anyways, okay, guys. Is this like a decent code review here? I think that was nice to actually discuss the options, so Luke can actually listen to this and think if we should alter this somehow. But yeah, I think both of your inputs are really important.
Yeah, eventually the output is not useful at all. I'm not sure how Luke will be able to use, because there's no gene identifier or anything here. But I'm sure he has something in his mind.
Yeah,
but
exactly.
I'm looking forward to seeing his ideas, because it doesn't make sense to store the data as it is.
So yeah, I mean my programming skills in JavaScript is very limited right now.
I'm in the same boat with you.
Yeah. So the problem is like I'm there just executing tasks because I have like a whole another world of dragons here that I need to fight every day. So basically, like I look it up and then I just go there and I do the task. And then I think with time I will have like I hope that in the next few weeks that I'm back listening to the meetings, I'll have a better, bigger picture about this whole Mist thing. But right now, I'm very focused on a single task situation. I think the next one will be chemotaxis shenanigans, which is going to be really interesting.
Yeah, I just, before the meeting, I just talked to Igor about his ideas of having some categorization on the genome page. So to give you an idea of how he envisions this, and so he thinks that to have 2 layers of classification, like as we had 1 component, 2 component chemotaxis. This is one way of classifying, and the other classification way, which is if it is vertical, that will be horizontal, is the functional, like transcription factors or cyclic IGMPs or RNA things, others, that kind of thing. So we'll have 2 layers of, so some transcription factors will be in 1 component system and some transcription factors will be in 2 component system. So that he wants to retrieve them as he wishes, like I only want 1 transcription, 1 component transcription factors, or all transcription factors, or all 1 components, and that kind of stuff. So we talked about it. It's very easy to implement as long as we have the categorizations from him. I also think about how to visualize that data, and I have a very good idea, I believe, which is actually using the JavaScript's cross-filter module. I'm not sure if you are familiar with it, but Amit is, because he also knows about it. If I let me share my screen to show you. So basically what we will have is we'll have gene list. It will be a table, and we will have categorization, like this is 1 component, 2 component, and 1s and 0s, or true or false.
Did you share your screen?
Actually, I did not. Let me do it. Screen 1. Share. Do you see my screen?
Yeah.
Great. So actually,
I remember this.
You remember this? So this is actually cross-filtering. Actually, you can do the same thing in Excel, but this is much more efficient.
Yeah.
So in Excel, what you do is you just filter in one column, and after that, from that, you filter another column. But here, you can say that, okay, I want all receptors, and this table is updated already, and you want all GPCRs from that, and this table is updated again. You can go back. And that kind of cross-filtering we can apply. What we'll have is the gene list as table, and it's not shown here, but the categorizations here at the other columns, like ones and zeros. And because we use SQL table, it will be very easy to implement. We don't need to rewrite the table. We can just read it from the database.
I agree.
So it will be very cool, actually. We can have the layers here, 1 component, 2 component, chemotaxis, and the functional layers here, and people can choose multiple dimensions.
Yeah, what I expect to become eventually is a platform that we can basically plug plugins to it. Plugins. Like, for example, this will be a plugin that we actually just glue to it, right?
I see.
We can also put taxonomy information.
Yeah, and then there's other things, for example, that I want to do in the future. Right now, we just actually need to work on a framework that can accept all this in the future very easily, right? You see what I'm saying? Because like we also need to publish a paper about MIST, and we need to release it. So the idea is, if we will work in a way that is easy to combine things later, this will be best. Because actually, I briefly talked about this with Igor yesterday, but I'm gonna share with you this idea. I've been having this idea, and then I think I'm gonna go forward even. I think we should go forward with this. That we make some other organization between us. Like, I don't know, a non-profit organization to actually focus in friendly code for biologists, like tools of bioinformatics for biologists. And the idea is we have MIST and SecDepot kept on what they are. So MIST is a microbial signal transduction database. SecDepot is a depository of sequences and information about them. And then we build plugins to these tools that actually will use them. And then we keep everything on the same roof in a very organized way, not like Slack. No, what's the name of the Slack style? They just have one line per group. Like we just make a bioinformatics umbrella basically of all the tools. Like I would like to include Aquarium, CDVist, and i5Pro, whatever Amit is working on that I don't even know about it. Yeah, but like, so the idea is we build all these things and then they're more or less plugging. I'm not sure, I'm not exact, because we're gonna keep working together, right? So we're gonna part our ways, and if there's a space like this is good for us to be part of a development team. We should give a name for this team, and then we should just keep doing this together. Am I clear? Like, I'm still thinking about this, but it might be confusing, but anyways.
I mean, we can do it, but why are you, I'm not sure why you're interested in something formal.
There is already an organization for it. It's called Zulin Lab.
We already have name.
What's the name?
Said it's Zulin Lab. There's already an organization for it.
You see, we need to be, Zulin Lab should be part of this organization, because like not too long from now, the Ortega Lab is gonna come to town. Ogun is gonna have his own lab, right? Everybody, you and me might have your own lab. I don't know what you want to do with your life. And
I want to work for a company. I don't want my own lab.
Yeah, so like, but like, I don't know what else you guys want to do it, but like we will actually build an umbrella of like other labs to be equally contributing to this thing, and then the Zulin Lab is part of it. because at the end of the day, the only way you can keep working on this together and not at trouble or tenure track is by being dependent from Igor. So if Igor owns it, I will have to stop working with you guys. That's the problem. Because everybody in tenure track should be independent from their PIs. Now, if we own it and Igor is just part of it, then that's a completely different story. Understand?
Yes, but why are you interested in something official that I don't understand? So we can also
curriculum.
Huh?
Curriculum. You put that on your CV, that looks great. You should see people actually coming here at Caltech in a job interview they had a hiring symposium for bioinformaticians. You should see what these guys are working. They're all part of an organization for bioinformatics stuff. There are tons of them. They're nothing. They're not even official or anything. They're just something. And they're part of a developing team, and then they push all these great tools that they make as if it's their own. It's like, these are what my team is working, but this one is my baby. And then they go through what their baby is. Everybody knows that they didn't build themselves, but they know that actually the ideas and the push and everything else is behind is from them. Like, so it shows leadership, it shows grouping, ability of a working group, and you automatically, I'm almost positive, you're automatically disqualified if you're not in one of those. If you're not a developer, and you won't be able to find a mid to high tier university job as a PI, at least not in US. What I'm seeing here is like everybody has a software.
I see. I would be happy to be in that group.
So especially if we start this now, and we start to be not completely independent from Igor, but the idea is like Igor will just be another member of this. If you start now, especially for me, it's going to look a little shady. But for you, since you're going to go through another postdoc in a different place, as it goes by, like you're a contributor, you're a developer of this, then like one of the developers, then when you get out of your postdoc, you can own this, right? Like you just hit on your chest, like this is my organization. I am equal as all the founders in there. And then the other idea is if you have a name, we can actually hire people for free. Let me explain that idea. We can have like summer code schools that we can actually talk to interns in whatever university we are, and actually have these kids that actually will do nothing with their summer to be non-paid interns, and then in exchange to that, we can actually give them the opportunity of learning. We build a crash course in team development, in developing softwares in teams, and actually try to actually have them like little tests, like building this thing. You know, even if they take a week, it's like a week that is 2 hours of our time that we don't have to spend. Imagine like you have like 5 of them. And they can put in their curriculum that they work for a certain organization. If you're not an organization, then they work for who? Or you're always going to be dependent on a single university to actually have this. It's a mess. It's much easier to actually, especially as a postdoc, you won't be very independent unless if you're part of something else. So you actually talk to your kids like, hey kid, you want to work for me? This is my deal. I work for with this organization, and then these guys actually are going to produce a code like this is what it's going to be. So if you want to work for us, that's going to be great. You can put in your curriculum afterwards. They will do it because everybody needs experience nowadays, and like these inexperienced programmers, even though they're good at it, people don't take it unless they have experience programming together with other groups. So I don't know. These are the benefits. The problems are the obvious ones, right? It's more bureaucracy, and one more thing for us to take care of. But what I'm seeing is basically like you need a web presence, you need a website, which we would build anyways, to port all these guys in the same roof and explain what we are, and then somewhat a legal presence, like something. It doesn't even need to be completely legal. You just need to exist somewhere.
So how would you have some funding for this organization?
See, there's no funding involved. We self-funded. Each one
How,
of us, we have our own funding.
where do you host your website, for example? How do you pay for?
Oh, we pay from our pockets. So you need to understand that we need from the start, right? So I have a server on DreamHost. I'll be more than happy to actually give away space, and we push our things in there for now. Like Igor can host the tools that we're building. Igor will be able to host most of them, and he owns them. There's a logo of the tool from his lab on it, right? But in our website, and there's a logo for our organization because we made it. For example, I'm not making any money working for Mist. Any. In fact, I'm losing money because I'm not working on my own projects. So the only recognition I can have for myself is if actually I participate on a grant project instead. If you are going to start keep working on these projects as you go in your postdoc, which I highly advise, you're still working for Igor basically, unless if you have an organization that will. Igor can even be the head of the organization, but I don't think. I think Luke should be the head of the organization, and we should be part of the board. That's the idea that I see. Eventually, we actually move forward to the point that we have this thing will have its own initiatives. Then Luke can start going for grants and actually self-funding to actually get funding for himself. Anyways, it's a seed idea, right? Just keep that in mind. Think about it, comes up with pros and cons, and then we keep talking about this. But I think it's something that we can all benefit from it, especially as young scientists.
So do you know the bureaucracy procedures for founding that kind of?
I know that opening companies and opening institutions in the United States is one of the easiest things to do.
Mm-hmm.
I know, especially if they don't earn any money.
Yeah.
I'll pay for it if that's the case, like $30. I suggest us to divide all the costs and we pay from our own pockets. But if nobody wants to put like $10 on it, I will do it. But the point is, we can. The idea is if you don't receive money, this is easy. To build a non-profit is a little bit more complicated. But this will be ideal. Ideally, we would have a non-profit, and then it would be like an organization. Igor kind of liked the idea. He thought it was crazy first, but then afterwards, he's like, I'm gonna give like a third thought because the second one was good. So
okay, non-profit means that you can earn money, but you cannot save it.
You can make money. Yeah, you can pay Luke.
Yeah.
Right? So the idea is like, this will require a lot to understand what Luke wants to do with his life, because if he can keep working for this organization, then actually that would free some money on Igor's budget. It's basically like I don't want to say this out loud, but it's basically like a way for Igor to actually spend less money on Luke and allow to have independent grants for Luke to work with all of us. So basically we all write grants for this organization, and then Luke will actually basically manage them and actually make his cut as a manager.
So is it going to be what kind of organization? Like, can you apply for grants?
Education, right? Like there will be it has to be an organization that can apply for grants. Yes.
Why can't you guys just apply for like a bigger project and be like co-PIs?
Because that will that can be, but it's nice to have a name on it. So for example, people build centers, right? Like what are centers?
But aren't they more formal? Like, I mean, if you apply to NIH, like, and you say that it's a group of 4 people, but
Right. I mean, so the idea here is like, you heard about the centers, right? Like Center for Bioinformatics, something, and then that is composed by 5 PIs from different institutions. This is what I want, but I don't know if you can actually make a center But in fact, but it would be nice to actually have something.
I don't think a
That
center would
direction.
work where everybody is in a different university.
Oh, there are centers that are like outsourced, like they are remote. For
Okay.
example, AJGMI is an institution that is completely separate from each other, right? Like they have AJGMI labs here at Caltech, at Stanford, Janidia Farm. They have like all over the place.
I think it's not called center. Center is an institution of
I,
to
I know. I'm just throwing names. But another thing would be an institute.
yeah
Actually, come up with an institute of blah 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 blah. You know,
yeah.
institute. I think. I think Grant. No, I think Igor thought I was actually. I had a few drinks when I wrote the email when I proposed the name for the institute is Institute Barry Taylor of Bioinformatics. So he immediately dropped the ball there. But I think he picked it up because I made good points after that. But so you can come up with like a cool name for an institute, and it's just being like this is what we are making, right? Like we are working together in these projects, and then the idea is like, oh, you're not independent. No, it's not like that. Like you're acquiring a new skill, which is developing softwares in teams. The trade-off is productivity, right? We're going to be able to actually push out not miss because it's taking too long because we are all learning now. But like I imagine that in 3 years from now, if you keep doing this, it's going to be way faster to make miss in three of us, five of us.
And not only that, so let me tell you one thing. I mean, it is independent from that institution thing. It is the value of working collectively and together.
Definitely, that's the point.
So what I built is a Docker images. Amit knows about it, but because I am more familiar with Python, I built three containers that work with each other. Actually, I use Flask and NGI NX to serve a web server which takes Python, which takes parameters and runs Python scripts. And it is beautiful. What you have to do is just implement your own scripts and just change the application script so that it will be ready for your new web application. So that I am sure you will love it because it is ready to go. All you need to do is implement your functions, Python functions in it, and it will go for it. So, for example, I would be happy to share it with you. I mean, I have no hesitation of doing that for any time. But with this togetherness, for example, if we don't work on MIST together, probably that's something that I wouldn't think to share with you because we are not in the same group anymore. We hardly see each other, and that's the value of doing something together. We can always share things, and I learned a lot from Luke about Docker, for example. I really appreciate about these things. So, anyways, so I really give value to that. It's nice.
Yeah. So I agree with this. And then, like, I think this is the future of our organization. You see, it's hard to actually give a name. What are we? We are working together. I don't make any money from Igor, and then soon Igor won't. So, like, what is this? It has to have a name. We need to be able to put this in our CV that we're spending 10 to 20% of our time working for something. I cannot tell that I work for Igor. He's not paying me, right?
I see the point.
So the point is, I think this should be the mission of and the vision of our organization. Would be the goal is producing bioinformatic tools for biologists. They should be super friendly, highly focusing visualization schemes, and highly documented. These are the three things that we need to actually work towards that goal. Now, the infrastructure is we're based on Docker. Everything we push it out is on Docker. So one of the things, which is the fourth thing comes in this mission idea, is our softwares are easy to install. This is the key for biologists to be able to use it. So I'm building my own phylogenetic profiling umbrella, basically. It's going to be something like what you said, Ogun. So you can basically keep pushing your own functions, and then you just, the idea is you can actually run an entire phylogenetic profile with one configuration software, configuration file. And then they spit out will be just basically another configuration file with all the final data, but not the raw data, that you can send to your collaborators. They can actually upload to a server and actually visualize the data, or they can actually install the PhyPro software and actually run again and manipulate the data any way they want if they want to double check the raw data. All based in MIST and SecDepo. So, and then for example, and then right now the tree is made with RexML. Oh, but I want to make the tree in PhyMol. Fine, build the function, write it the way, and change the configuration file for you, and then you can actually do a pull request after you fork it, even if you're not part of our organization, and then actually now has the PhyMol, it's supporting PhyMol. You install on the Docker machine, you push it up, all done. You see what I'm saying?
Yeah.
So if we work in all our projects like this, then we are going to, for example, Aquarium. I don't want to use the visual interface of Aquarium for what I need. But I need Aquarium to actually do, it's how I define my proteins. I define my proteins based in domain architecture. I define my protein families based in domain architecture. That's how my PhyPro works. Right now, I'm doing by hand. But ideally, I would have Aquarium database served together with MIST. So I can actually go and do a pull from the Aquarium database. I can actually search the Aquarium database straight from my PhyPro. What this requires is that Aquarium needs to be up to date, just like MIST. So we need to actually make that pipe go, right? We need to actually make it with Aquarium. Every time you update MIST, it updates everybody.
Right.
So, and I think this is very powerful, because then, Ogun, you can actually hire a master student or even an undergrad, a summer student, to work with you on the front end, because you don't have to worry about the back end anymore. So there is a big thing, right? Like, one thing is to hire a summer student, a high school student, or like an undergrad to do front end work is easy. Hire them to actually build an entire software from scratch is way harder. So let's just do the hard work in our spare time, and then actually hire like inexperienced students to do the cool work, where they can learn. You don't have to do it. They are creative. They work on the front end, and then actually we build tools. Right? They actually able to build tools. They build one or two functions. I can easily see there is a project for a summer student. Port Python, port PhyMol to my PhyPro. Easily. 2 months, they can learn enough Python to do, they can get familiar with the documentation, they can write the code, test, do a Docker file, push it through, boom, commit. Now, if I ask them to actually work in anything else without this structure before, it's impossible to actually do any good project that's going to be useful. An example is all the rotation students that come through Igor's lab. What has they ever made that was useful? No, it's true, right?
Well, many students are biologists coming to Igor's lab. There's no computer scientist.
Yeah, but this is, you see, you take this biologist and tell them, here's how Markdown works. Write the documentation. Done. They write the documentation, they're part of the development team, they can explain, we teach them about functions. If they learn how to program in 3 months, awesome. If they don't, fine, write the documentation. You get something out of it, they get something out of it, golden. Instead, Igor puts them to actually go through Excel tables and other stuff.
Well, it looks like research, but writing documentation doesn't.
Well, it does, because they're going to have to do exactly what Igor asked them to do. For example, they need to understand why the protocols that we use, or where they put publications. They're gonna, by doing the documentation, they might suggest better ways of doing something. Or at least you're gonna realize that there's a better way of doing something when you read what they wrote in the documentation. This is very, very useful. It's so useful that Luke actually asked if I want to be the expert for documentation. And no, I don't have time for that right now. But you know, like it's a very serious business, and like nobody wants to really do. But it's very, very useful. And then also they're gonna have to actually learn how things work. So they have to learn JIT. They have to learn few computational tools and bioinformatics. I think it looks like research when you're doing it. Plus, they do rotation. They don't have to do research. They have to be in contact with the research team. Can be useful, which they're not. Anyways, I'm only here shenanigan with you because my meeting got pushed to 1:30. So. Anyways, so you guys understand more or less the idea. Maybe it's like a problem because we're gonna have to go through the bureaucratic hoops of it. But I wanted to be able to justify me spending time working on these projects. And right now, I basically can't.
Is it your biggest motivation? Or
it is, because like we can keep working the way we're working. It's just fine. It doesn't mean
No. I'm asking, behind the idea of founding an institution, is this one is your main motivation, or you really want something that changes the world?
No. I don't think it's gonna change the world. I think it's gonna have 500 of them. But like the point is, like we need to belong somewhere, and we can't belong to Igor's lab. We just can't. I mean, it's people are gonna tell me straight up like you have to be independent from your PI and your postdoc advisor, or your PhD advisor and your postdoc advisor. Oh, fine, we are all independent from Igor on the programming things, but no, they don't know. Right? We're building our tools based like on some of the Igor's input, but like the tool that I'm building, there is no input from anybody. Right? Like there's like small little suggestions, but like I came up with the entire thing with the vision and everything. Nobody will believe me. If this gets published or pushed under our team, this will be seen out there as Igor's work.
So are you going to write your institution in the paper?
No, I will write my own, but then I will start there's a lot of showing on this, especially when you're in your department. If you start pushing like 1 tool a year, people are going to say like, oh, is it going to become a matter of status? Right? Like, oh, this guy's the developer of this team. They're really good. They make all these tools. You see the difference? Like if you're from EMBL, like, oh, you're from the EMBL. Or you will see that it's a lot of show off.
So you have a host name and serve each tool as the subdomain from that host name?
Yeah. Well, maybe
it would
not.
be ideal, I believe.
Well, yeah, but like maybe you, for your own independence, you would actually host your own tool. But for example, wouldn't be so bad for you, for example, as a postdoc, to be able to host your tool in Igor's lab, because he gets a kick out of it. He's in the publication set anyways. But you can also have a place to host independent from your postdoc advisor. Even though it's in Igor's computer, Igor is part of the organization. He's only contributing with like the server. And then I think if we play this right, in 5 years, we'll be writing grants for our own thing. So then you don't even need to actually claim that it's in Igor's computer anymore. It's just in the machine. It can be in my lab too. Actually, this is one of the things I want to propose to Graham when I leave. It's like I want whatever our organization becomes to be mirrored and served from Caltech as well. And if I go, I don't know where I'm going, like the University of Blanc-Gandin, I want them to be served there. And then when you actually get your position, you serve the same. We serve mirrors everywhere, you know?
Okay. You can, sure.
Yeah. And then I think, and then this is another, I like this idea. I didn't think about this, but I like this idea. We can have just subdomains of each one of the tools, like cdvis.organization
Exactly. Exactly. This is
com.
exactly. This is
I
how
like
it's
this.
supposed to be.
Yeah, this is. I think this is really cool. Yeah, and we have like more or less. If you have the same principles, this can be really, really golden. Like visualization first, we want people to be able to manipulate the data in a smart way without actually doing massaging, right? Like which people do a lot in statistics. You need to be careful with that. But then I think this can really, really work. I don't know, just something to keep in mind. I think Igor is not. Igor didn't shut down the idea immediately. And then I say, and I think he's gonna be on board too. The only thing that I don't think we can expect Igor to have time to lead this. He shouldn't. We should lead this. It's not a revolt against Igor. It's just trying to be a little more independent and to find a way to keep the ties among us. It's a lot of show off. At the very end, this is all for show because we already are committed to work together. It doesn't matter. We're gonna do it. It's just a cooler way of showing off, you know.
Yeah.
Especially in small departments, in small universities, right? Like, hey, this guy comes in, he's part of this big group that's making all these cool tools in bioinformatics. Boom, you already have status. It can be useful for all of us. I mean, even if you go to industry, you can put in your curriculum that you actually are a postdoc in Igor's lab, and you're a postdoc? Yeah, you are a postdoc. So you are a postdoc in Igor's lab, and did Amir get eaten by the dog or something?
No, they're playing. I'm sorry.
Okay, no, it's okay. So even though when you go to industry, but like telling people that you work in a group development team, this is very strong because a lot of scientists will never do that ever. They don't even know what Git is.
Yep.
Now, if you just say like I work in Igor's office, I can have two things that you do at the same time. You're multitasking, but it's the same thing. It's show off. I'm not kidding. It's just show off.
Yeah, looks like it. Why don't you just get to bureaucracy steps and we'll see what needs to be done and let's see what Luke will say.
Exactly. The first things first. The first step of all is actually get Igor on board. Not because it depends on him, but out of respect.
Sure.
So Igor needs to be fully on board of this, otherwise we just keep doing what we're doing, which is fine by me. But it's much easier for us to find a job by being part of this. And it's actually look good for him too, to be like someone part of an organization to build this kind of softwares. And then actually can tell everybody that his students made this organization. Right? I mean, it looks good for him. He's a senior PI now. It's great. He's gonna look like, wow, this guy this guy's so good that his students made an organization that now pump softwares all over the place. Fantastic. And I think the best beneficiary for this will be Luke, because then he can basically, if we get like the funding situation going, if you can actually make this official, we can basically have this running its own grants, and Luke can actually be more independent manager. Like have less uncertainties about his own future. I don't know if he needs that, but I'm just thinking that I would like to have that if I was in any position. Anyways, this is the idea. I'll be very interested to listen to what Luke has to say, and definitely we're gonna wait for the go ahead from Igor on this.
Mm-hmm.
Hey, Ogon, did you see we've been cited, man?
What?
Our CDVs is being cited.
Yeah,
Oh,
I saw
by the
that.
way, wow, two other things. Cool. Okay, another thing that I was going to tell you is I didn't wrote CDVs, but I heavily participate in the design and production. So I'm listing myself as a developer. I hope you're okay with that.
I am.
No, I'm listing me as a developer.
Yeah.
You're okay. Okay.
Okay.
I'm putting that I'm a part of the developer team that is designing, because now that I'm seeking jobs everywhere, I'm putting. This is why I came up with this organization idea. Now it would be much simpler to say, I am board member of this organization, and then put the website, and then they will look. There's several softwares in it. Like right now, I have to actually say I'm a developer of MIST, or SexDepot, or CDVs, and 5 Pro, and so on. It's like a freaking nightmare. So in any case, if you ever get like a letter or any email, just confirm that
Sure.
I am also a developer of CDVs. And also, I imagine that we're going to build CDVs 2 eventually. So
Build what?
I imagine we're going to build CDVs 2 soon.
Yeah, I've started to implement CDVist in a Docker container. So I already started that.
Oh, that's very great.
And because I want it to be portable, so you never know what will happen. So right now, if something happens to the server, then it is dead. I mean, I have to spend a lot of time to get it back on another server. So this is my kind of one of the priority things to do before I start my new job. I will make it portable, and I'm kind of changing the algorithm a little bit. I mean, I'm adding an option. Anyways, we can discuss it later.
Right.
So anyway, let's discuss it later. It's a long story.
I even like the name BioWalls for the organization. It can be any name. We just need to come up with like a website that looks like it's official. It doesn't even need to be official, to be honest. People just go in, it's like, wow.
It doesn't look serious though.
No, I know. BioWalls, it's out of question. But we just need like to have one very cool, slick website with all the tools that we make. Very good documentation. Very, very good documentation. Very scientific. Quoting papers all over the place, explaining how things work, and then everything needs to be published in good journals. This can be really cool. And then eventually we can actually, if this organization becomes a thing, we can put as a second affiliation of each one of us being part of this organization in our papers too.
This is what I asked.
Yeah, in the future, yes. You're part of, I don't know, Chapel Hill, whatever, and is that where you're going? It is, right?
Yeah,
you're part of Chapel Hill and this organization, the BioWalks. Very cool. And we don't even need to have an address. You can have like a postal, a PO box. We're good to go. We just need to actually look into the bureaucracy of this, and then like I'll be more than happy to head this if everybody's on board. I will ask Luke a lot of help because I'm pretty sure he knows a lot about this legal stuff. I also have a couple of friends that are lawyers, but this looks really good when you actually go find a job as a PI.
Okay, so we can also let Luke watch this video to have an idea, or you can talk to him.
I think I'll talk to him because I think even though it's everything I said here, I think it's obviously public and recorded for posterity. I think it'll be more productive to listen to his questions as it goes. So like it'll be easier to actually maneuver the subject.
Yep.
He probably had like one question right in the beginning, and now he's just listening to gibberish. It's true. All right, guys.
All right.
Thanks very much. This is very cool, and I'll talk to you guys next week. We should try to do this. I like this. I always assumed that without Luke, the meeting is gone. The meeting is not happening, but we should actually keep the meeting rolling because this is kind of cool.
Sure. So for next week, I'll be moving on Friday, so I'll be at my new home. I may not be able to connect you. I may not even have internet access, so just keep going, and I will watch it later.
Right, very cool. Yeah, I don't know anything about Docker containers yet. Look, Ogun, but I'm. This is the future. This is definitely the future of our organization, whatever this shit is.
Yep.
Anyways, all right, guys.
All right.
Talk to you guys later.
Take care.
Thank you.
Bye bye.
Bye.